Hello everyone, my name is Aryan Bhandari and this is Java course by DoCoNation. In previous session, we learned about inheritance and types of polymorphism in Java. But in this session, we'll be learning about abstraction, interfaces, and encapsulation in Java. Before starting the session, let's know about this static keyword because we have been looking at this word since our first session. So let's discuss about this first. So whenever you create a method as static, that means that it is the property of a class now, and you cannot access it using the object of that class. So let me explain you with an example. Let me create a class car, okay, and let's just say that it has some property like number of gears, okay, and some method, okay. Let's just say public void run. It just starts the car. Okay, so now if I make this method as static, then I can directly access it using this car2 name. So earlier what we were doing was we were creating object of the car, right? So like this car2 and some object name equals new car2. Like this we were creating and using this object, we were calling this method. But now without even using this object, we can call this method. So we can simply remove all of these and just write run like this. So now if I run it, so it's gonna directly call it without using the object, as you can see. Right? Similarly, if I write this property as static, now similarly I can even call this or use this without even creating an object of car2. So I can simply just write gears and let me just print it. So now if I run it, as you can see that it's calling this field without even creating the object of this car2 class. Okay, so why this main method is static? Because when the Java compiler compiles it and the JVM need not instantiate an object for it to call it, it can directly call the main method. Now let's talk about abstraction. So by the definition of Google, abstract means that a thought or an idea without a concrete existence. Okay, so if I make this class as abstract class, so I will just have to put abstract keyword in front of the class. Now this class is an abstract class and I cannot create object of this class now. So if I try to create object of this class like this, so it will give me an error. It says you cannot instantiate the type car2 because it is an abstract class, and abstract means it's just the idea or without a concrete coding in it, right? So if we try to create the object, it will not make sense. Let me explain you further. So in abstract class, we will need to have abstract methods only. So how we write method like this, right? Void, let's just say it has some gears into it, right? And you can just simply put abstract keyword in front of it. Okay, so this is a abstract method. Okay, now what this tells, whenever you extend this class car2, whenever you're gonna extend through any class, you have to implement this method. Okay, so I'm just idealizing it. I'm just creating a structure out of it. So I would say, let's just say that a car will have a gears, right? A car will have some kind of engine, powering engine, right? The power of the engine will be different. So I can simply create different methods for that. Okay, like power of engine. Like this also I can create some method. Okay, so I'm just preparing a structure in my abstract class. But when you create a class, let me just comment this one so that it won't be confusing. Now, if I use another class, let's just say there is a class name BMW, which is gonna extend this car2. Okay, so now it's giving me an error. So it's telling add unimplemented methods. So that is what this is. Okay, so we have to implement this method. So if I click on it, see it's created me a method which is gears, because I have to implement it inside this method. And because I'm overriding it, this is also known as runtime polymorphism, as I have taught you in my previous session. Okay, so that's why this annotation is over here. Now I can define this method inside my this class, and now I can create object of this class. Okay, so I can create object of this class, BMW equals new BMW, and I can use b1 dot gears. Okay, and I can simply print like this, has 6 gears. So if I run it, it will run. Okay, why abstraction is done is because to hide the complexities from the users. Okay? Suppose in a car, a user wants to change the gear. So he doesn't really require to know all the engineering behind changing of a gear, okay? The exact mechanical thing happening behind it. He just needs to, push the gear lever up or down so that he will be able to change the gear. So that's what he needs. So we are hiding all the complexities from the user. That is why abstraction is used. Suppose if you tell any user that I'm selling this car, just take it. So he will ask that what car are you gonna give me, right? Which brand it is. So you can just tell no, it is just a car, you just take it. So that can't happen, right? So it is just a idea or a structure, and then when we extend any class, okay. So if we extend this car to using any class, then we have to implement this method. So now I can make one more class like this. So I can give this uh, integer like number of gears. Okay. And similarly, I have to write this over here also. And now I can simply copy it and create another car. Let's just say Polo. And I can simply just say like this number of gears in it. Okay. And similarly over here also. And while creating the object of the car, I can simply pass the number of gears. So 6 I'll pass over here. So I don't care whatever is there inside this car. Okay, so this car might have engine like I already showed. Okay, power of the engine or whatever is there, that I don't care about. I have to implement some methods. Okay, and I can simply pass my values around it. So I can just extend the car, and I'll get all the properties of car, and then whatever I want to input my extra properties, I can do that. Okay, so similarly, if I create an object for my Polo class, so I can write like this, and I can call my gear. Okay, and I can pass 5, right? So if I just run it, so it has 6 gears. So this is for the BMW one, this is for the Polo one, right? So this was about abstraction. So in Java, you can achieve abstraction using abstract keyword, or you can also achieve abstraction using interfaces. So when we use interfaces, we use implements keyword, and when we use inheritance, we use extends keyword. Okay. So just like abstract keyword, interface is similar to that, but it provides us true abstraction. Why? Because in my abstract class, I can simply write like this also. So I can actually create a concrete block inside my abstract class. Okay, but if I make this class as interface, this will give me a error. Okay, so yeah, it is giving me a error. Okay, so it is telling me to remove the method body. So if I remove this, the error will be gone. So it provides us true abstraction. But there are some exceptions, like only private and default methods can have the body. Like if I make this as a private a private function like private void start, so I can use this. Or if I write a default void uh, here, I can write these two methods as concrete blocks, but other than this, it provides us true abstraction. So to use interface, we use implements keyword. So if I want to implement this car2 in BMW, so I have to write implements car2, and okay, I did not pass this. So now it's giving me an error because see, it's telling me to change the method visibility to public, because when you implement an interface and the methods inside it must be the public methods. Okay, so let me just change it and just made it public, and I can similarly use this, right? And let me just comment this one and let me run it. Yeah, so it has 6K, so it ran this one. Okay, so this is how we use interface, right? So in my previous session I showed you that we cannot extend many classes, right? So we cannot extend like this. We cannot extend dancer also and some other classes also, some blah 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 classes. We cannot do that. We can only extend one class. Okay. But in interfaces, we can implement as many as classes we want. Okay. So let me just create another interface. Let's just say it is car3. Okay. Now I can just put comma and write car3 over here. Okay. So now it can implement this car2 class also and this car3 class also. Okay. So if I create any method over here like public void engine, see it's giving me error. What did I do wrong? Because I need to remove this concrete block statement. I cannot write that. Okay. So now it's giving me error in this also because I have to implement the unimplemented methods, which is this method, because I'm implementing this car also now. So I have to implement this method also. Okay. Now it's okay. Now it's not giving me any error. Right. So we can now use this also. Similarly, we can add many more classes interfaces. Okay. So we cannot use multiple classes and create a child class out of it, but we can use multiple interfaces to create a child class. Okay, so like this is the child class and these are the interfaces. So we can implement all of these at once. And in interfaces, when you define any value like power, say 10, so by default this will be final values. Okay, by default this will be final values. Okay, now what is a final value? So final is a keyword. Okay, final and power equals 10. So let me just comment this one. So this is equal to this. Okay, now this final keyword does not allow you to change this power. So once you have declared this power keyword with a value of 10 and put a final behind it, that means now you cannot change this value any further. Okay, and in interfaces, the any field you declare, that is final by default. Okay, now let me just try to change it. So over here if I write dot power, so I can actually print this. Okay, I can actually, let me just this, I can actually print the power, right? So if I run it, it prints 10, but I cannot change this like this b1 dot power to some other 120. Okay, so it's giving me an error. It's giving me the final field car2 dot power cannot be assigned. See, it's giving me final field. I have not written final keyword, but by default it is final in interfaces. And a class, when you implement this class, you have to define all the methods which are there. Okay, and you need not define all the fields, it depends upon you, but you have to define the methods which are there inside the interface classes. So you have to define it in the class, whichever class is implementing those interfaces, and these methods are by default abstract methods. Okay, so these methods, so even if you write abstract over here, that will not change anything, because by default these methods are abstract. Okay, now you must be thinking about this uh, public, and what is this I showed you, this private and default, what are those? Okay, so those are known as access modifiers. So what are access modifiers now? So access modifiers concepts comes when we speak about encapsulation. So let's jump into encapsulation. So in previous session, I was explaining using the example of robot. So let's just take the same example. Okay, let me remove all of these. So we had our robot made there, and now let's make the brain of the robot right now. Okay, so let's just say there is a class named as brain. Okay, so it's the robot's brain. Okay, so we can write some values like this, right? Like the name of the robot, and we need to write some uh, chip number. Okay, like int chip number, and we'll pass some 2019. Okay, now let's just see that if I write like this, so anyone can access this chip number, but I want that no one should access this chip number except from the admins, okay, who are authorized. So here comes the power of access modifier. So what I can do, that I can make this as private. Okay, so let me show you. If I create a class of brain, sorry, if I instantiate brain, so new brain, and if I try to print this b1 dot chip number, so it's giving me an error. Why? Because see, it's telling me to change the visibility. Okay, because it is private and no one can use it or see it. But if I remove this private keyword, it's gonna remove this error, and if I run it, it shows me the chip number. Okay, so this I don't want, so that's why I'm using private keyword. Okay, so similarly, like private keywords, we have public, we have protected. So this is how, so this is protected. Okay, and we have default also, as I showed you. Okay, and we have our private. So public, when you declare public, the field will be, or the method will be accessible to all the classes, packages, subclasses, to the whole world. Okay, and when you make it protected, it will be only be visible to classes, packages, and subclasses. Okay, and when you make it default, it will be only accessible to the classes and packages. Okay, and when you write it private, so this value will be only be visible to the same class only. So if I write private over here, so it is only available to this class. So in this class, if I write some method like this, and if I print my chip number, so this will not give me any error, because private fields are accessible inside the same class. Okay, but let's just say I was talking about giving powers to the admin so that they can change the chip number. So how do we do that? So we have functionality given by Java known as getters and setters. So right click, go to the source, and go to generate getters and setters. Okay, so it will open this window. So for what do we need getters and setters? So we need for this. Okay, so if you click on this arrow, it will ask that you need both of these functions or only one. So I need both of these, and I just click on generate. Okay, see, so it's generated for me, get chip and set chip. So using these functions, I can actually set the chip, okay, for changing the chip number, or I can get the chip for displaying the chip number. Okay, see, directly I cannot get it. It's giving me an error. So let me just remove this. So when I use this, how can I use this get chip? Simply I can use the object of b1 and just write get chip. Okay, so if I run it, it will print the chip number. So I'm not using the main field, right? And now it is not vulnerable like it was previously. So now how to set the chip? See, it's already given me a code, this dot chip number to the chip number which I'm gonna pass. So if I uh, pass a chip number, like let me make it 2020, and this won't return. So this was to just set it. So I'm gonna set it, and then I'm gonna print the chip number. Okay, like this. If I print, so 2020, so it was 2019. I used set chip and I made it. So what we can do actually is, let me just create a scanner class for taking the input. So now what I can do, whenever someone is trying to set the chip, so what I will do is, first I will ask the password. Enter the password to set the chip number. Okay, and now I'm gonna take that password in string. I just say in pass variable sc dot next. Now what I'm gonna do, I'm gonna create a password that will also be of private field. Okay, so private string password is equals to, let's just say, Aryan at DoCoNation. Okay, so this is my password. Now this password will only be given to the admin. So this is like a layman term I'm explaining you, but to understand, uh, I have created this password as Aryan at DoCoNation. Now it will ask the password, and if the password which I got is equals to the, so we are using string, so we will use dot equals. Okay, if it is equal to this dot password. Okay, so this means this class password. So whatever password I'll get, okay, whenever someone is trying to set the chip, it's gonna ask enter the password to set the chip number. I'll get the password of the user in this variable. I'll check with my system password whether it is right or not. So if it is right, I'm gonna set this chip number. I'm gonna just remove this code from here and paste this over here. So I'll set the chip number, and I'm gonna print the message also. So if you have set the chip number, you have successfully changed the chip number. Else, else if you type wrong password, it will show wrong password. Okay. Now let's try to run this. Okay. So my first chip number is 2019. Let me change to 2021, and let's run it. Okay, so now it's asking me to enter the password to set the chip number. So if I write some other password like Aryan, it's gonna say wrong password, and it's printing the same chip number. Okay, so it did not change. Now if I let me run it again, and let me write the correct password, and it says you have successfully changed the chip number and it is 2021, right? So this is how encapsulation is used. So this was the basic of using access modifiers and getters and setters. And why this encapsulation is done? So encapsulation is actually done due to security reasons, right? So I do not want to uh, give my chip number or make it visible to anyone. Okay, so this is very crucial to a robot, right? Because a robot will go crazy if the chip number or something happens with the chip, right? So that's why it is done due to security reasons. Okay, and encapsulation means wrapping up data into single unit. So for due to security reasons, and we were doing abstraction, or we were using interfaces due to reduce the complexity from the user. Okay, so this was it for the session, and we'll see you in the next video.